Math people. All right, for today's lesson, we're going to be looking at Chapter 3, Lesson 3, which is using ratio tables. So if you're a note taker, which I would encourage everyone to take some notes, I'll get your heading. Chapter 3, Lesson 3, ratio tables. All right, I'm going to go through what a ratio table is, as well as how you can use ratio tables to solve ratio problems. We'll do a couple examples, and that'll bring us to some practice problems later. First off, the question that we need to answer is, what is a ratio table? So first I'm going to show what a ratio table looks like, and then I'll define what a ratio table is. All right, so on the screen you can see a ratio table, and since some of you might be trick-or-treating in the near future, I've got a ratio table that's comparing the ratios of Snickers to Reese's. So you can see from my ratio table that for every one Snicker you get when you are trick-or-treating, you get 4 Reese's because Reese's are superior. That would mean that for every 2 Snickers I get 8 Reese's. I went big. For every 5 Snickers I get 20 Reese's. Let's write a couple things about this though. Number one is all of the things in a ratio table are equivalent to one another. Number two is how can I generate other values in a ratio table? I'd say there's 2 ways. You can generate values in a ratio table the same way that you would get equivalent fractions, which is to get from a 1 to 4 ratio, I'm getting there by multiplying both parts of the ratio by the same value. 1 times 2 and 4 times 2 takes me from a 1 to 4 ratio to a 2 to 8 ratio. 1 to 4, 2 to 8, both equivalent to one another. I see another jump here. To get from a 1 to 4 ratio to a ratio of 5 to 20 would mean I'm going 1 times 5 and 4 times 5. So one way to form equivalent ratios is to multiply both parts of the ratio by the same value. Another way to form an equivalent ratio, think of equivalent fractions, is I can make the fraction or the ratio smaller, and the way that we do that is through division. So for example, if I wanted to get from 5 to 20 down to a smaller ratio, like let's say we wanted to get back to this 1 to 4, how do I get there? Well, from 5 to 20, both of those values can be divided by 5. And so something equivalent to 5 to 20, which is already in the table, is 1 to 4. But I'm just highlighting another way to form ratios in a ratio table. If they're always going to be equivalent to one another, the 2 ways that you can form equivalent ratios, one way, make the ratios bigger by multiplying both parts by the same value, or number 2, divide both parts by the same value. So what I just said, there you can see it written out. To form equivalent ratios in a ratio table, you can either multiply both parts of the ratio by the same value, like we can see here with the red and the black writing, or divide both parts of the ratio by the same value, like you can see with the blue writing here. From here, let's go to some example problems involving ratio tables. Our first example says, find the missing values in each ratio table and write the equivalent rates. So I've got a 1 to 3 ratio of triangles to sides. So for every 1 triangle I have, there are 3 sides to the triangle. That's a true statement. So if I'm going from a 1 to 3 ratio to a 2 to something ratio, I know the jump from 1 to 2 is times 2. And whatever I do to one part of the ratio to form something that's equivalent, I do to the other part. So I'm going to multiply by 2. This is going to make a 2 to 6 ratio, which is equivalent to 1 to 3. You could probably figure out the rest of this table on your own, but let's work it through. To get from 3 to 9, I know that I could multiply times 3. And whatever I do to one part of the ratio, I do to the other part of the ratio. So 1 times 3 brings me to a 3 to 9 ratio, which is equivalent to 1 to 3 and it's also equivalent to 2 to 6. So far everything in our table is equal to one another. The last ratio is a 4 to something, and I see two different ways that I could get there. One way is I could start with this 1 to 3 and use it to get to the 4 to something ratio. I know to get from 1 to 4, so to get from 1 to 4, I could multiply by 4, right? 1 times 4 is 4. 3 times 4 would tell me that the missing value is 12. Another way to get there is I see the 2 to 6 ratio could also be used to get me to the 4 to something ratio. 2 to 4 would mean I need to multiply by 2. Whatever I do to the first part of the ratio, I do to the second part of the ratio, so that would also get me to 12. Either way, the last missing value in this ratio table would be 12. All right, I'm going to give one more example similar to this one. I would encourage you to pause the video and see if you can fill in the missing pieces of this table. We've got a ratio of frogs to toads, for those of you who are amphibian lovers, and I want to get to box, I'll call this box A, box B, and box C. Let's see if you can get those values. Then you can unpause and check. All right, to get from 4 to 20 is times 5, so to 6 to box A is also times 5, so box A would be 30. 30 toads for every 20 frogs. To get to box B, how can I get from one of these values to 90? Well, if this is a 30, box A, I know to get from 30 to 90 would just be times 3, so that's the jump I'm going to use, though it's not the only way to get there. So that means on the top here, I'm also going to multiply 20 by 3, which tells me that box B is 60. Lastly, I'm looking for box C. So I know on the bottom here, I need to get to 180, and there's a couple things you could do. You could go from box 6 to 180, that'd be times 30, so 4 times 30. You could also go from box A, which is 30. 30 times 6 is 180, so 20 times 6 is 120. Those are the two routes I would go. You could pick either of those two, but no matter what you do, you should get an equivalent ratio of 120 frogs for every 180 toads. And everything in this table is also equivalent. All right, let's look at two more examples together, and then we'll be done. Again, find the missing value in the ratio table and write the equivalent ratios. The first one that's here is pretty straightforward, but we can take a look at it together. If you want, you can pause and see if you can get it on your own, but I'm seeing from 100 to 300 is times 3, from 300 to 900 is also times 3. So let's get those values first. 1 times 3 is 3, and then I'm doing another jump of times 3, which is 9. And that gives me my last from 1 to 8 is times 8, so 100 times 8 is 800. So there's your completed ratio table. Now the second example that I have for you is a little bit trickier because you can see there's a fraction in this table. So I've got for every 1 minute I travel 3 meters. The first missing box is not too bad. 1 to 2 times 2, 3 to 2 would be 6. So 1 to 3, 2 to 6, those are equivalent ratios. For the second missing value, I've got how many minutes does it take to travel 2 meters? Well, how do I get from 6 to 2? That's the jump I'm seeing. I think the easiest thing here would be to divide by 3. 6 divided by 3 is 2. That's a pretty nice connection, which means whatever you do to the first value of the ratio, you have to do the same thing to the second. Divide by 3. Now you could give one of two answers here. 2 divided by 3 means that it would take 2/3 of a minute. Or if you wanted to actually find the value of that, you could do 2 divided by 3 and give the decimal value of the answer. So either is fine. I would just leave it as 2/3 of a minute, or the decimal value is fine too. That'd be 0.6 repeating. All right, now the weird one. How do I get to 5/3 from any of the values that I have here so far? A couple things you could do, but I think the most straightforward way to go is I can get from 1 to anything else in the table, because anything times 1 is that number. So 1 times 5/3 is 5/3, which means that all I need to do to get this top value is multiply by 5/3. So 3 times 5/3 is 5. So in 5/3 minutes, I can travel 5 meters. And there's the missing value of that ratio table. If you'd like, I've got one extra example that involves a fraction. I'll put that up on the screen. Pause it, give it a try on your own, and then come back and see if your answers are good. 1 times 5, so 4 times 5 is 20. Now, to get from 20 to 5 or from 4 to 5, I think the easiest thing to do is to divide 20 by 4, which is 5. So that means here I'm going to do divide by 4. So 5/4. 5/4 of a gallon, I can travel 5 miles on that. You could also get an exact answer on that, 1.25 if you want a decimal value. Then lastly, how do I get to this 9/4? You can do all the jumping through hoops that you want. The most straightforward way to get there, though, is to get from 1 to anything. You just multiply by that value. So 1 times 9/4 is 9/4, which means 4 multiplied by 9/4 will get me my missing value in the table here. So 4 times 9/4 is 9. So with 9/4 gallons, I can travel 9 miles. All right, last example that I'm going to do with you before I cut you loose is a word problem, because why not? This problem says that a nutrition label shows that there are 75 milligrams of sodium in every 12 crackers. So if you looked at the back of a box of crackers, it might say something like that. Now you don't stop at 12 crackers, you're hungry, you want a good snack, you eat 30 crackers, and you want to know how much sodium you consume. There's plenty of ways that you could solve this problem. One way, though, is organizing your data in a ratio table. So I'm going to set that up real quick. It takes 2 seconds, it's not that hard. We're going to go with sodium to crackers. Now I know that it tells me 75 milligrams of sodium is in 12 crackers. Ultimately, I want to know if I eat 30 crackers, how much sodium do I consume? I'm noticing there's not a direct way to get from 12 to 30. So I left a blank spot in the table so that I can get to some little stopover that can take me to 30. And you've got tons of options here. I'm going to go over 2 options that I see. One is I could just simply divide 12 by 12, and that gets me 1 cracker. And if I know how much sodium is in 1 cracker, I can get to 30 crackers by just multiplying by 30. So that would mean my math involved here would be 75 divided by 12. That would tell me how much is in 1 cracker, and then get to 30 crackers. And that's 6 1/4, 6.25. Multiply that by 30, and you get to your final answer. And that should be 187.5 milligrams of sodium. So that's one way that you could attack this problem. Some of you might have seen a different connection, though, and the other way to do this, let me clear out my table, is instead of going down to 1 cracker, you might have, if you know your facts very well, you could have said, 12, if I divide that by 2, is 6, and I can get from 6 to 30 by multiplying by 5. So you see, you're looking for ways to connect to numbers in the table by keeping things equivalent. So cutting 75 in half, dividing by 2, is 37 and a half. And then to get from 6 to 30, I multiplied by 5. So my jump up here would be 37 and a half times 5, which also gets you to 187.5 milligrams of sodium. Like I said, ratio table, not the only way to solve this problem, though it is a tool that you could use, and we're going to encourage you to use it from time to time. We'll be doing plenty more practice with ratio tables in class tomorrow, so make sure you have your notes, any questions you might have, and we'll see you then. Later, math people.